This is what I call the carbon capture module. In fact, it's only a single prototype fan unit of the carbon capture module. It's a very small component in a very big vision that will remove sufficient CO2 from Earth's atmosphere to make a measurable difference. I'm an old chemist and chemical engineer. Up in here, it's just running on water right now, so it's safe. There's a spray bar. Here we have a 5-gallon graduated bucket of a solution that will react with carbon dioxide in the atmosphere. Over there we have a gallon, 4 liters, of captured carbon. I'm the founder of an organization or a startup company called Sacred Earth Enterprises, and our business is the business of climate restoration. What is climate restoration? Firstly, it's the daunting task that we must accomplish successfully if our future generations, our children, our grandchildren, are to inherit a safe, habitable Earth. Secondly, it is an urgent global initiative to restore Earth's climate to its pre-industrial state. Climate restoration presents a multi-trillion-dollar investment opportunity. There is an estimated 1 trillion tons of carbon that we humans have placed in Earth's atmosphere since the beginning of the Industrial Revolution. That trillion tons is accessible to us. It's free for the taking. Think about that. Think like a miner. That trillion tons can replace the concrete, steel, and aluminum industries. How's that for an investment opportunity? This instrument is a carbon dioxide monitor. As you can see, it reads 410 ppm, which means that the local air contains 410 parts per million of carbon dioxide. That's pretty much the global average right now. Let's put that into perspective. Homo sapiens has never before existed in a time when the carbon dioxide content of Earth's atmosphere was above 300 parts per million. Why is this important? It's important because carbon dioxide and methane and a few other gases are greenhouse gases, which means that they accumulate in the atmosphere and they prevent the sun's heat from leaving planet Earth, from escaping through the atmosphere and harmlessly going back into space. Can we remove a sufficient quantity of CO2 from Earth's atmosphere to make a difference? That's the business we are in. Carbon dioxide removal from the atmosphere is a significant part of our operation, and we have just built and tested the very first carbon capture module, which is something we'll be talking about as we go along here. So just as a reminder, 410 parts per million is a disaster. We know that. We've known that for a long time. We all know the problem, but how many of us know the solution? Is there a solution? Is there one single solution? My answer to that is no. There's a set of solutions. There are a number of things that we must do if we are to survive as a species. There's a consensus. The consensus is this: we must stop burning fossil fuels. I think all of you know that. Secondly, we must start extracting what we call the legacy carbon dioxide, the trillion tons. We must make an immediate and massive start on removing that carbon dioxide from Earth's atmosphere. And finally, number 3, the third leg of the climate stool, we must begin to reflect the sun's infrared heat back into space in a safe and harmless manner. We have strategies for that. My relevant personal training is in chemistry and chemical engineering. And this machine here, the carbon capture module, is the simplest imaginable chemical engineering system, and it runs on chemistry that I learned at the age of 14. How does it work? Carbon dioxide is acidic. It reacts with any alkaline substance to form a new compound, such as calcium carbonate, also known as limestone, or sodium bicarbonate, commonly known as baking soda. These two compounds do not create global warming or climate change. Calcium carbonate, limestone, can be used in concrete. Sodium bicarbonate can be turned into a number of other products. The one I'm most interested in is carbon fiber composite material for 3D printing. What does that mean? It means we literally can take the carbon in Earth's atmosphere and use it to build anything we can imagine. Cars, planes, boats, trains, buildings, cities, space stations, built from the carbon in Earth's atmosphere. This little machine, the carbon capture module, is part of a much larger system. The one we're looking at here is just a single fan unit of a full-scale carbon capture module, which actually contains 16 such fan units. And that is part of something we call the Sacred Earth EnviroPlex. The Sacred Earth EnviroPlex incorporates an entire array of carbon capture modules. A full-scale EnviroPlex will have 128 of these carbon capture module fan units, all running 24/7 and capturing carbon from Earth's atmosphere every minute of every day. That's our next goal, to build a prototype EnviroPlex based on this technology. Our business model calls for these systems to be mass-produced and globally deployed. Here's my idea. Go to the most polluted cities on Earth: New Delhi, Los Angeles, Mexico City, Beijing, the list goes on and on. Each group of 1 million inhabitants receives an EnviroPlex. The EnviroPlex captures carbon dioxide. Yes, that's true. But it also does much more. The very first thing it does is to clean the incoming air. It filters the incoming air and removes from it pollutants, particulate matter, things that cause massive health problems. The building provides organic food, carbon-free energy, purified water, livestock feed, employment, housing, education, and job training. It's a community center. The multipurpose pavilion can be configured according to the local community's needs.